Hello everyone, we are from section 7 group 6. Today our main topic is about pulse amplitude modulation PAM. So before we go to PAM, let's start from the basic PMS pulse modulating system. So what is pulse modulation system? Pulse modulation system are the technique used to encode analog signal into a series of discrete pulse. The key character of pulse, such as width, amplitude, frequency, or position, are related according to the signal being transmitted or controlled. The fundamental theory behind PMS lies in the principle of converting continuous signal into a form that can be easily processed, transmitted, and reconstructed in digital system. From this diagram, we can see that we have 4 types of pulse modulation, which is PAM, PWM, PPM, and lastly PCM. Today, our topic is mainly focused on PAM. So what is PAM? PAM is a fundamental technique in the signal modulation where the amplitude of each pulse is varied in a proportion to the instantaneous value of the message signal. From this diagram, we can see that the modulating signal, which is the signal is information to be transmitted times by the sampling signal will become modulated signal. The sampling signal is a periodic train of narrow pulse with phased wide and fixed spacing. And lastly, after they times and combine, they will become a modulated signal, which is PAM. In this modulated signal, we can see that the pulse timing and wide time remain constant, but only the pulse amplitude change following the shape of original baseband signal, which is followed by modulating signal. In short, PAM represents an analog signal by a sequence of pulse whose amplitude track the message signal.
So let's start with the basics, how the pulse amplitude modulations or PAM works. So imagine you have a smooth flowing voice signal. In PAM, we don't send the whole wave. Instead, we take a snapshot of the height at regular intervals. So this is called the sampling method. So to make sure that we don't lose any details, we must follow the Nyquist rule, which is taking a sample at least twice as fast as the signal's highest frequency. So we use the high frequency carrier signals of pulses and adjust the heights to match our original message. Essentially, we are turning a continuous wave into a series of stepping stones that follows its path. And there are two different types of sampling techniques, the natural PAM and also the flat-top PAM. So the first method is called the natural PAM. This is a theoretically pure way to sample a signal. So let's just imagine that it is like a gate that opens and closes very quickly. So because of the gate is open for a short moment, the top of each pulse is not flat. So it actually keeps the exact curve and slope of the original wave. This sounds perfect because it does not cause any distortions, but it rarely used in real life, as the curved pulses are very hard for electronic equipment to measure accurately, and they are easily ruined by background noise or interface. Next, we have the flat top PAM, which is the industry standard used in things like speakerphones or digital audio recorders. Instead of the gate, this method uses a sample and hold circuit. It grabs the signal's height at a specific moment and frees it, creating a perfectly flat rectangular top for the pulse. This makes it much easier and more reliable for digital hardware to read. The only catch is a slight distortion called the aperture effect, but engineers can easily fix this later with the cool, call, and equalizer. Now, how do we actually create these pulses? We start with two main signals, our analog message, like our own voice, and a pulse generator. These signals will go into a modulated circuit where the sampling happens. The pulse generator acts like a clock, telling the circuit exactly when to measure the signals. If you are using the standard flat-top method, the circuit takes a snapshot of the voltage and holds it steady for each pulse. The result is a sequence of pulses that stay with the same width but change their height to follow their message. Finally, how do we turn those jagged pulses back into a smooth sound? This is called the demodulation process. When the pulses arrive at the receiver, we first use a holding circuit to stretch them out, turning the spikes into a staircase wave to boost the signal's energy. Then comes the most important part, the low-pass filter. Think of this like the polisher. It blocks the sharp, high-frequency edges and connects the dots to reveal the original smooth voice signal hidden inside. And just like that, the original message is restored.
Next, I will explain the simulation of natural pulse amplitude modulation, starting from the transmitter and then the receiver. At the transmitter side, the message signal is a low-frequency analog signal. This message signal is multiplied with a periodic pulse train. Because the pulse remains active throughout the sampling interval, the pulse amplitude follows the shape of the message signal continuously. As a result, the output is known as natural PAM, where the pulse stops are not flat but vary according to the message waveform. At the receiver side, the natural PAM signal is passed through a low-pass filter. The low-pass filter removes the high-frequency component introduced by sampling and allows the original message signal to be recovered. In the time domain waveform, we can observe that the amplitudes of the pulse changes smoothly with the message signal. This indicates that the signal is sampled naturally without holding the amplitude constant during the pulse duration. From the recovered signal, we can see that the original message signal is successfully reconstructed, although slight distortion or attenuation may occur due to filtering and system imperfection. Now I will explain the flat-top PAM simulation, which is more commonly used in practical communication system. In flat-top PAM, the message signal is first sampled and then passed through a sample and hold circuit. This circuit holds the sample amplitude constant for the entire pulse duration, producing pulses with flat tops. At the receiver side, the flat-top PAM signal is again passed through a low-pass filter. The filter smooths the signal and reconstruct the original analog message. In high domain waveform, the pulses have a constant amplitude during each sampling interval. This makes the flat-top PAM more stable and suitable for further digital processing, such as analog to digital conversion. The recovered signal closely resembles the original message signal. Compared to natural PAM, flat-top PAM provides better control over sampling and is less sensitive to timing variation. In summary, natural PAM is simpler but less practical, while flat-top PAM is widely used in modern communication systems due to its stability and compatibility with digital processing. So, next is the recent advancement in PAM. Used in modern analog to digital converters, ADC, applied in smartphones, IoT device, and medical sensor. Multi-level pulse amplitude modulation, MPM, used in high-speed Ethernet optical fiber communication, enables higher data rates without increasing bandwidth. So what's the impact on society? Enables accurate sampling of real-world signal, support reliable data acquisition in healthcare monitoring system, Internet of Things, IoT, and smart device. Improves signal processing efficiency in digital communication system, forms the foundation of modern analog to digital conversion. So here's the benefit to the society. Provides clearer and more accurate medical signal readings, such as ECG, enhanced audio and sensor quality in smartphones and consumer electronics, reduces power consumption in electronic device, extends battery life and lowers operational costs, contribute to environmentally sustainable technology. Thank you. That's all for me.
Now we would like to say some common misconceptions about PAM. The first misconception is that PAM is outdated and no longer used. It might sound true at first, but actually it's not correct. In fact, PAM is still used today and play an important role in modern communication system, especially as a step before signal become digital. Another misconception is that higher pulse amplitude always improves signal quality. However, it also not true. If the pulse amplitude becomes too high, it can cause distortions and noise, whereas the signal works instead or better. So from here, we can understand that PAS must be used carefully and more is not always better. Next, let's talk about the healthy and safety consideration. PAS systems usually operate at lower power level, remain safe to use in electronic device. They also comply with international safety standards, meaning they are designed to meet safety rules used around the world. Because of this, PAS system has no significant health risk to user, especially in daily devices like smartphone and sensor. Now, let's move on to the legal consideration. Communication systems that use PAS must follow communication and spectrum regulation. These regulations are important because they help to prevent interference with other communication systems. By following these two, different devices and systems can work properly without distributing each other. Next is environmental consideration. Efficiency use or PAS can use reduced power consumption in electronic device. It also help to extend the battery life of device, which is very important for portable electronic. However, this contributes to sustainable as environmentally friendly technology is beneficial for society. In terms of community education development, understanding basic communication rules is important. System UPN must still follow communication and spectrum regulation. It helps to ensure that communication systems do not interface with one another and can be used safely by anyone in the community. In conclusion, PM play a critical role in communication system by enabling the conversion of analog signal into a form suitable for digital processing. While there are several techniques for implementing PAM, flat-top PAM remains the industry standard due to its stability and compatibility with modern systems. Although challenges such as amplitude noise persist, PM continue to serve as the foundation of advanced modulation schema and will remain mature in the future of digital communication technology. That's all for our presentation. Thank you. Before we finish, we have prepared a mini quiz for you. This quiz is based on only what you just learned for our site, and this is simple, short, and designed for beginner. So there's no need to worry, and the Google Form link can be found in the decisions and comment section. We encourage everyone to join the quiz to test your understanding and have study fun learning together. Thank you very much for your attention.